Hello, welcome to today's class. In today's class, we will discuss about macro preprocessor, and we will see what are the different data structures that are used by the macro preprocessor. So far, whenever there is a macro call, we performed macro expansion, but we performed the macro expansion manually. However, when we assemble our program, at the time the macro expansion has to be performed by the software. So the software that performs that processes the macro definitions and which performs the macro expansion for macro calls is called the macro preprocessor. So the macro preprocessor, here is the schematic of the macro preprocessor. So the input to the macro preprocessor are programs which have macro definitions and macro calls in them. And the macro definitions and the macro calls are processed by the macro preprocessor, and the output of the macro preprocessor is a program which do not have any macro definitions and which do not have macro calls. All the macro calls are expanded, and hence the output of the macro preprocessor is a program which do not have any macros. And this program now can be assembled by the assembler to create the target program. So this is the general schematic of a macro preprocessor, and the different data structures that will be used by a macro preprocessor are listed here. So we need a macro name table, we need a parameter name table, we need actual parameter table, we need keyword parameter default table, we need expansion time variable name table, we need expansion time variable table, we need macro definition table, we need sequencing symbol name table, and sequencing symbol table. We will see all these tables through an example. In this example, I have one macro definition and we have a second macro definition. So the program consists of two macro definitions. I have not shown the main program here. Later on I will add a macro call, but for the time being, to process the macro definitions, I am just listing two macro definitions here. And now when we process the macro definitions, these are the tables that will be required. We will need the parameter name table, and the parameter name table will store the name of the parameters. For example, when we process the definition of the first macro, in the first macro we have three formal parameters. So these names will be stored in the parameter name table. The next is the expansion time variable name table. This table is used to store the names of the expansion time variables. Again, if we look at macro number 1, here we have one expansion time variable v. So this name will be stored in the expansion time variable name table. Next is the sequencing symbol name table. So in this table we will store the names of the sequencing symbols. For example, in the first macro we have one sequencing symbol more. So this name of this sequencing symbol will be stored in SSN tab. Then we have the macro name table. In the macro name table we will store these informations about the macro. We will store the name of the macro. For example, the name of the macro is clear. Then we will store how many positional parameters it has. In this case we have two positional parameters, so the value in this entry will be 2. The next column is number of keyword parameters. So here we have only one keyword parameter and that value will be stored here. Next is the number of expansion time variables. Again, in this macro I have only one expansion time variable, so this entry will be equal to 1. Next is MDT pointer. So this is a pointer to the macro definition table. So as we will see later, in the macro definition table we will store the definition of the macro, and the definition of the macro starts at, for example, what we will store in the macro definition table is the statements starting just after the prototype. So this LCL statement will be stored in this macro definition table, and since the macro definition table will initially be empty, the first macro will be stored starting at entry number 1. So the MDT pointer for the first macro will be 1. So this entry tells us where in the macro definition table the macro is stored, starting location of the macro in the MDT, that is stored in this table. After we store the first macro, some of the entries will be filled up in the MDT. So the second macro will start at some other entry. So for the second macro, its MDT will not be 1, it will be the first empty location available. This will be more clear when we go through the example. Moreover, we store a pointer to the keyword parameter default table. So initially for the first macro, this table is empty, so the first empty location in this table is 1, so the value in this entry will be 1. Similarly, SSTP is a pointer to the sequencing symbol table, and since this table is also empty, this value will be 1 for the first macro. We will go through this when we go through the example, it will be more clear at the time. Next is the macro definition table. As I already said, the macro definition table, we will store the definitions of the macro in the macro definition table, and we will store statements starting after the macro prototype statement up to the macro end statement. So for the first macro, we will have 1, 2, 3, 4, 5, 6, 7. 7 statements will be stored in the MDT. Next is the keyword parameter default table. In this table, we will store the default value of the keyword parameters. For the first macro, I have only one keyword parameter, and it has the default value A register. So that pair register equal to A register will be stored in the keyword parameter default table. Next is the sequencing symbol table. So for each sequencing symbol, where the sequencing symbol is defined, for example, the sequencing symbol more is defined in this statement, and now this statement will be placed in the MDT, and in which index this statement is placed, that index number will be stored in the SS tab. Again, it will be more clear when we go through the example. So let us try to fill up these tables for the first macro. So for the first macro, the prototype is here, the name of the macro is clear, and hence for the first macro we enter the name in the MNT, and in the parameter name table we store the name of the parameters M, N, and register. Next, we count how many positional parameters are there. There are 2 positional parameters, hence we enter the number 2 in this particular entry. Next, we count how many keyword parameters are there. There is only one keyword parameter, so I enter that number here. So far I don't know how many expansion time variables this macro will have, because we are only processing the first statement. We have not yet seen the complete macro. Only after processing the complete macro I will know how many expansion time variables are there. So this particular entry will be empty initially, but I do know that this macro will be stored in the MDT starting at index 1. Hence the MDT pointer for the first macro, which is clear, will be 1. Again, for the first macro, the default tables will be stored starting at index 1 of the keyword parameter default table. Hence this pointer will also be equal to 1. Similarly, the sequencing symbol information will be stored in SS tab starting at index 1. Hence this pointer will also be equal to 1. So initially the MDT is empty, the keyword parameter default table is empty, and SS tab is empty, and that's why for the first macro all these pointers are 1. For the second macro it will not be the same, as we will see later. So after processing the first one more thing, we have the default values of the keyword parameters, and that has to be entered into the keyword parameter default table. After that we go to the next statement, and when we process the next statement we encounter the first expansion time variable, and that name we enter into the expansion time variable name table. So whenever we come across an expansion time variable, the name has to be entered into this table. The next thing we will do is we will enter this line into the MDT, and when we enter it to the MDT, please note that this name of the variable is replaced by the index in the expansion time variable table. Since V is our expansion time variable, we use the notation E, and this particular variable is stored in index 1 in the expansion time variable table, and that's why we write E1. So wherever V appears, V will be replaced by E1. So that completes the processing of the LCL statement. Then we will go to the next statement, and the next statement again we enter it into the MDT, and as you can see again V is replaced by E1. With that we will go to the next statement, and again we will enter it to the MDT, and this time please note that register happens to be the third parameter in the PN tab, and hence your register has been replaced with the notation P,3. So this is a parameter, hence we write the notation P, and register happens to be the third parameter, hence we write it as P3. So wherever register appears it will be replaced by P3. So after this statement we go to the next statement, and when you come to the next statement we get the first sequencing symbol, and we enter it to the sequencing symbol name table. That's the first thing we do for this statement. Next we enter the statement to the macro definition table, and as we enter the statement to the macro definition table, again register has been replaced by P,3, and this time we have another parameter M, and M happens to be the first parameter, hence it is written as P,1 plus the expansion time variable V, and V is replaced by E,1. So that completes the processing of this statement. We go to the next statement. One more thing before we go to the next statement, as this statement have the definition of the sequencing symbol. So when the sequencing symbols appears in the label field, we call it the definition of the sequencing symbol. So this statement defines the sequencing symbol, and this particular statement is stored in MDT entry number 4. Hence this index will be stored in the SS tab. So again I'm telling it again, the sequencing symbol more is defined in this particular statement, and the statement is entered into the MDT at index number 4, and hence this index 4 is stored in the sequencing symbol table. Next we go to the next statement, and this statement is again entered to the MDT with V replaced by E comma 1. And then we go to the next statement, and that particular statement is also entered into the MDT. This time N is replaced by P comma 2 because N is the second symbol in the parameter name table, and sequencing symbol more is the first sequencing symbol, hence it is S comma 1. And then we go to the next statement and we enter it to the macro definition table, and once we reach the macro end, the processing of this macro definition is complete. And since it's complete, now I can find out how many expansion time variables were present. So if I look at the expansion time variable table, there I had only one expansion time variable, hence I update this entry in the MNT, and the number of expansion time variable is 1. So among all these tables, the parameter name table, the expansion time variable name table, and the sequencing symbol name table, they are used only at the time of macro definition processing. So when we process the macro definition, only at that time these tables are used. Whereas the other tables, so after we complete the processing of the macro definitions, these tables can be removed. However, MNT, MDT, sequencing symbol table, and the keyword parameter default table, these 4 tables will be used at the time of processing the macro definition, and later on they will be used also when processing macro calls. That means when performing macro expansion, at that time also these 4 tables will be used. So these 4 tables we cannot remove, they will stay. Whereas after completing the processing of the definition of the macro, after completing the processing of the macro definition, these 3 tables can be removed, but these 4 tables cannot be removed. And one more thing, and these 3 tables are macro specific. For example, right now they store only information about the first macro, whereas these 4 tables, they are common to all the macros. For example, MNT will store the information of the first macro, and MNT will also store the information about the second macro. Similarly, MDT will store the information about the first macro, it will store the information about the second macro also, and so on for the other 2 tables also. However, these 3 tables are macro specific. And now, since we have completed the processing of the definition of the first macro, these 3 tables actually can be removed, but these 4 tables will remain. And after we complete processing of the first macro, we will now process the definition of the second macro, and for the second macro we will create this table one more time. And now for the second macro, the name of the macro is eval, so I enter it to the MNT, and number of the parameters has to be entered into the parameter name table. Here we have 1 2 3 4 parameters, so we enter the name of those parameters into the parameter name table, and then we count how many of them are positional parameters. X and Y, they are positional parameters, so I include the value 2 here. And Z and register, they are keyword parameter, so the number of keyword parameters will be 2. Number of expansion time variables I will know only when I reach the end of the macro. Right now I am at the start, so I don't know how many expansion time variables. And now this particular macro will be stored in the MDT starting at index number 8. So for the second macro, MDTP will be equal to 8 because the second macro will be stored in the MDT starting at index number 8. Similarly, information about the second macro will be stored in KPD tab starting at index 2, hence this pointer will be equal to 2. And similarly, information about sequencing symbols will be stored in SS tab for the second macro starting at index 2, hence the SSTP pointer will also be equal to 2. So after entering this information of SS tab in SSTP, next we need to include the default value of the keyword parameters into KPD tab. So we have two default values for parameters Z and register, and we enter the default values in this table. Next, we need to process the first statement after the prototype, and in the very first statement we encounter a sequencing symbol, and that sequencing symbol is entered into SS name table, sequencing symbol name table. So here the sequencing symbol is only, and it is being entered into the table. Next, this statement has to be entered into the MDT, and as we enter this statement into MDT, the sequencing symbol is replaced by S,1 because only is the first sequencing symbol, so it is written as S,1, and Y and Z. Y is the second parameter and Z is the third parameter, so Y and Z is replaced by P,2 and P,3. With that, we will move to the next statement, which is a move R instruction, and this statement is also entered into the MDT with the parameters replaced with register is the fourth parameter, so it's replaced as P,4, and X is the first parameter, so it's replaced as P,1. Next, same thing is done for the subtract statement, and similarly for add statement. And now for AGO, we encounter the second sequencing symbol of this macro. The name of the sequencing symbol is over, so over is also entered into the sequencing symbol name table. And next, when this statement is entered into the MDT, over is replaced by S,2 because over is the second sequencing symbol, so it's written as S,2. And next we go to the next statement, and it's a move R, so the statement is entered into the MDT, and as we enter the statement into MDT, please notice that the sequencing symbol is not added here in the MDT. However, this is the definition of the sequencing symbol, and this definition and this statement which defines the sequencing symbol only has been entered into index number 13, and that 13 has to be placed into SS tab. And with that, we move to the next statement, and next statement is a macro end statement which we enter into the MDT. Again, you notice that the sequencing symbol is not written when the sequencing symbol appears in the label field, that is not written into the MDT. However, this statement was defining the sequencing symbol over, and this statement appears in MDT in index number 14, so 14 is placed into the SS tab. So in this way, we complete the processing of the macro definition of the second macro also. One more thing was left, which was filling up the expense and time variable. For the second macro, we don't have any expansion time variable, and hence the number of expansion time variable is 0. And now we can remove these three tables, because these three tables are used only when processing the macro definition. We don't need them anymore. Since the macro processing of the macro definition is complete, we can remove them. And let me make some space here. So let me take these two tables to the top, and let me add now a macro call to the program. So I am adding a macro call. So this is our main program. I am not shown all the statements, and in the main program I am calling the macro clear. And now for this macro call we need to perform macro expansion, and macro expansion will also be done by the macro preprocessor, as you know. And now we need to create one more table, which is the actual parameter table, and the actual parameter table will store the actual parameters. In this macro call we have two actual parameters, area and 10. So those two actual parameters are entered into the actual parameter table. However, if you notice that for clear, if we go to the entry in MNT for clear, and this is the entry for clear, and there you can see that we have three parameters, two positional parameters, one keyword parameters. However, in the actual parameter table we have only two actual parameters, so one actual parameter is missing. So we go now to the keyword parameter default table, and for this macro, keyword parameter default table starts at index 1 of this table. So in index 1 we look for default value, and default value is a register. So this a register is entered into the actual parameter table. So we have the values for all the three parameters now in the actual parameter table. We need to create one more table called the expansion time variable table, and this table will store the value of the expansion time variable during macro expansion. So in our case we have one expansion time variable, so we'll allocate space for that one variable. Next we need to start macro expansion, and to start macro expansion we look at the MDTP pointer for clear. For clear, the MDTP pointer is 1, which means in MDT starting at index 1 I will find the code for the macro clear. So starting at we have to perform macro expansion starting at index 1 of the MDT. So we initialize our macro expansion counter with the value from the MDTP, and now macro expansion counter is pointing to the first entry into the MDT. And if we process the first statement, it is defining an expansion time variable, so nothing much will be done. We already have allocated space for the expansion time variable, and then MEC will be incremented to 2 so that we process the next statement. And next statement says that you increment the value of the first expansion time variable. So the first expansion time variable should be set to 0, and that's what will happen when we process the second statement. This is happening when we are doing the macro expansion. So notice that this index that we preserved helps us updating the exact expansion time variable. So in this example we had only one expansion time variable, but in case you have 2 or 3, that particular information will be maintained in the MDT as E1, E2 or E3. So here it says E1 should be set to 0. So if the first expansion time variable is set to 0, we get the index number automatically. So with that, the processing of the second statement is done. So MEC will be incremented to 3. And in this, now this is a model statement. So model statement has to be generated. And now when we try to generate, we need the value for parameter number 3. So we'll get the value for the parameter number 3 from AP tab, which is A register. So for the for the third statement, the code that will be generated is move our A register, 0. So this A register we got from the actual parameter table, and which of these 3 actual parameters should I use is already mentioned here as parameter number 3. So in this way, the macro expansion will be performed till we reach the macro end statement, and the code will be generated. So what we saw is these 4 tables, they are used when processing the macro definitions, and they are also used when performing the macro expansion. And whereas these 2 tables, they are only used when performing the macro expansion. And the other 3 tables, parameter name table, expansion time variable name table, and sequencing symbol name table, those 3 tables that we had removed already, they are used only at the time of processing the macro definitions. So with this, we saw how the macro preprocessor use the different data structures to store different informations, and using these tables, how the macro definition is processed and how the macro expansion is done. So now we can write a program to make use of these tables as part of your lab class. I will also try to send some code which may help you. So have a look at those code when you receive. With this, I would like to end this class. If you have any questions, you can post it through Piazza. Thank you.